Welcome to our introductory video about our new digital project mapping ancient narratives, territories, and objects, or MANTO for short. Of course, MANTO was a figure from ancient myth, the daughter of Tiresias and a seer in her own right, and we're happy that our project's acronym takes part in a bit of meta-reflection on what we're trying to do. That is, to map the ancient Greek mythical story world, the figures that take part in it, and the places and objects involved. This mapping is, however, not only cartographic, but also relational. So even if we can't plot an event on the map, we can uncover the relationships between agents and the places that are described. What you're looking at right now is our new public platform, currently being tested and refined at manto.nodegoat.org. In the second video, we'll be showing you how you might use it to explore the world of myth. For the next few minutes here, however, we're going to show you the back end of the project, its history, its data structure, and what our goals are. MANTO was conceived out of a frustration with existing tools and a desire for a new digital asset, a sort of digital mythography that would be able to capture essential data from ancient texts, while also allowing that data to be organized and analyzed at scale and from different perspectives. In 2018, Greta Hawes of the Australian National University and Scott Smith from the University of New Hampshire came together to establish a working methodology that would achieve our aims. First, to create a relational database of connections between entities, places, and objects, MANTO. Second, to allow for cartographic plotting of the mythical entities and events when possible. Third, to offer the potential for network analysis between different figures. And fourth, the creation of a standard database for mythical entities that has a stable URI for other digital assets to tap into. It's important to understand what MANTO cannot do. Most importantly, because we are breaking down narratives into individual data points, it does not capture the whole fabric of a story. Instead, it captures individual pieces, the threads of the fabric, if you will, in a process of disaggregation. But we recognize that something is lost in the process of capturing our data. Turning to our ontology, that's the term used to establish the organization of the data in the database, that's based on the idea of a semantic triple, which is basically the structure of subject, predicate, direct object that allows data to connect to the wider linked open data environment. In our ontology, the subject and object can be an agent, heroes or gods who do things, places, or objects. As for the predicates that link together the entities, the directors and team of dedicated students have spent 2 years refining the list, and there are currently some 200 individual predicates that helpfully define the kinds of relationships and actions that are typical of the Greek mythical story world. In addition, we have added to the basic triple statement a series of prepositional phrases and other connections that allow agents and objects to be connected together in various ways. It would be helpful to show you some of the data that was recently captured by a student working on Euripides' Alcestis. The opening of the text is Apollo's speech that provides the background of the action. Zeus's killing of Apollo's son Asclepius, Apollo's killing of the Cyclopes in revenge, and Apollo's servitude under a mortal, and so forth and so on. Now, before entering the data into the database itself, we start with a rough draft, something like this. As you can see, we start with the basic semantic triple. Our first entry will be Apollo is slave of Admetus. We then add the additional information about where, in Pherae. And we have other relations that we can express as well, for example, at the instigation of Zeus. Next, we have Zeus kills Asclepius. And because he uses an object that we've captured elsewhere, we can use using Thunderbolt. Next, we have a relationship that is expressed in Asclepius is child of Apollo. And because we have the gender attached to the actual entity, that will be represented in the computer code as son of. And finally, we have Apollo kills the Cyclopes. And in this case, we have it to avenge his son Asclepius. Now that we have the data, it's time to go to the database itself. We use a third-party server called NodeGoat, which allows humanities researchers to adapt and modify the ontology and the data in order to fit what they're trying to do. Let's now go to the database and add some of the data we just captured from the Alcestis. In NodeGoat, we have several tabs that allow us to get at the actual data from a number of different perspectives. We're going to go to Tie. We're going to then add a tie, which is basically a new data point. We always add the start passage and the end passage so that the users of the public interface can find the passage and consult it if they feel it's necessary to check our own work. We then move to the semantic triple, adding the subject. In this case, it's going to be Apollo. And because we already have the entity Apollo, we can just click it. The predicate is slave of, and that will be entered automatically because it's one of our predicates. And finally, we then move down to the location. Where is this happening? It's happening in Faireye. Again, it's already populated, so we can just click it. Because of our particular language, we use the term of for servants and slaves. Now, there are two admetases, so we have to make sure we get the right one. This is Thessalian, the Argonaut. You'll notice there's a number of other items that we can add at the command of, at the instigation of, to aid, to avenge, etc. Plus, there are other ways of identifying what kind of data is contested when there's a textual problem, and other things for notes as well. Our next tie, we also add the passage. Again, this is 3 to 4, Alcestis. The subject in this case is Zeus. The predicate, of course, is kills. That's auto-populated, and then we go to Asclepius, allowing us to complete the semantic triple. You'll notice that the semantic triple in the previous data point did not have an object. That's not a problem because we can also attach it to location and so on. Here we have the prepositional phrase using, and because Thunderbolt is already populated in our database, we can simply call it up as an entity. Then we click Save Tie, and then we're done with that. And now that we've captured the data, these will be added to all the other data captured and can be organized in various ways. Here, the data from the Alcestis will be added to those from Apollodorus, Homer, and Pausanias, all of which can be pulled up at the simple click of a button. Let's now move from tie to entity. Let's take a closer look at one figure, Jason, and what MANTO can do. We can access all the data for Jason by simply typing in the name. This brings up all the entities with someone named Jason or someone related to Jason. We'll click on the Argonaut. This brings up what we call the file card, which is the data organized with information drawn from the data we've entered. Some of the auto-populated data shows family relations, parents, children, marital relations, and affiliations with larger groups, in this case the Argonauts, as well as the Meleager Caledonian boar hunt. In addition, it also currently shows all related entities, which may not seem very helpful, but with network relations, it will be quite helpful indeed. One of the really cool aspects of this digital project is that it allows us to visualize the mythical story world. One way is by mapping the data at scale. Here we can see the map of the data captured so far. In it, you see that 4 points are highlighted: Iolcus, Jasus' homeland; Colchis, land of the Golden Fleece; Corinth, and Athens. A larger dot represents more data points associated with the area, while a smaller dot means fewer. But what about Athens? How is Jason associated with that area? The great thing about this project is that it allows us to go and find the data through the place itself. So we click on it. And this brings up the sanctuary of the Dioscuri in Athens, and the file card tells us all about it. If you want to find out more, you can then go to the cross-reference and find all the data points associated with it. That brings up the first one with Jason. We find out that Jason, along with the other Argonauts, including the Dioscuri, are actually depicted in the sanctuary itself in an artistic representation. Let's click out of the map and go back to the file card of Jason. You'll notice that on the file card, you can also highlight other entities, and you can go to their file card just by clicking on that as well. We have clicked on Medea, and now we have her file card available to us. And similar to that of Jason, we find ourselves with data already organized, including family relationships and so on. In addition, though, we also have some other information, like who Medea has killed, as well as the places that she is the eponym of. One of the things that MANTO tries to do is to tie the historical world back to the mythical world where places were said to have been founded. We can also map the places with which Medea is associated. Because Pausanias looms so large in our data set right now, Corinth has a large dot with lots of data. But you can also try and look and see what other places that she's associated with. For example, let's take a look at Anafe, an island in the Aegean. Again, you can access the data just by clicking on the place itself, and that will lead you to further information about how Medea might be related to the island. Of course, Anafe is the island that Apollo showed to the Argonauts as they were sailing back, and of course, that's why the Argonauts and Medea set up a sanctuary of Apollo on the island itself. So, where is the project now, and where is it headed? At present, we have nearly 6,000 distinct entities, agents, collectives, places, landmarks, and objects, as well as over 11,000 individual ties. One of the core principles that we settled on early was that the data needed to be curated, which is why the available data is partial and the project remains a work in progress. Thus far, the team has captured data from the text that would likely give them the biggest mythological bang for their buck: Apollodorus' mythological handbook, the travel writer Pausanias, Homer's Iliad, and Hesiod's Theogony and Works and Days, as well as a few other smaller texts, such as Plutarch's Life of Theseus and the Lindian Chronicle. It is a long-term project that aims at being comprehensive as well as user-friendly. Our next set of texts to capture will be the geographers, many of whom mention the locations of myth as they organize the world around them spatially. We invite you to visit our website, manto-myth.org, for more information about the project, our blog about the difficulties of dealing with mythical material, and a link to our data, among much else.